What is metamerism and what are metamers? When two isomers have same functional group but have different nature of the alkyl group or the aryl group attached to the heteroatom, we call it as a metamerism, and the isomers are called as metamers. Let me explain this concept with an example of the ethers. Ethers have a general formula of ROR, and the functional group here is oxygen. Now let's take an example of the ether, CH3, CH2, OCH2 and the CH3. Here you got two ethyl groups on the two sides of this oxygen, right? So this is the ethyl group, this is another ethyl group. If you write down another molecule having the same formula, but the groups around this alkyl, around this oxygen will be different. Let me take here the CH3, CH2 and CH2 group to one side, 3 carbons to the one side, and another one has a one alkyl group on, has a one methyl group only. Okay, so this is ethyl and this is ethyl. Here you have a propyl group and you got here a methyl group. So these are the two molecules which are called as metamers. Why? Because they have the same functional group, same formula, but the alkyl groups are different. Here you got in this first example two similar groups around the oxygen. Here you got a methyl and a propyl. The formula is same, right? You can see here 4 carbons here and the 4 carbons here, one oxygen here, one oxygen here. Hydrogens are again the same, right? So the formula is same, functional group is same, but the only difference is that around the ethereal oxygen, around this polyvalent functional group, you have two different alkyl groups attached to it. Here you got ethyl and ethyl, here you got a propyl and the methyl. So these are the metamers, right? Let's take one more example of the metamers. We got the C4H10 oxygen, and let's write down the different metamers of this molecule. You can see here the 4 carbons, all right? We have 4 carbons, and you can write down different, these metamers. One is having the methyl, and the other side has a propyl. The second metamer has 2 ethyl on the two sides of this oxygen. Here you got isopropyl group and a methyl, right? This is different than this one. This is a normal propyl and propyl, and here you got an isopropyl group to the oxygen and methyl from the other side. So these are actually the 3 metamers of the C4H10O compound. Let's write down the metamers of this compound. Here you got an ethereal oxygen here, and then it has a one phenyl ring here, and from the other side it is C2H5, right? CH2, CH3. We can write down the different metamers of this compound. For example, if you have a CH3 here and then you got this CH2 and this benzene ring, right? You can rearrange it. You can have this CH2 here, right? And then you can have a CH3 at this position, or you can have it at the para position, this meta position, or you can have it at the para position, right? So these are the 4 different metamers of this compound. The only difference you find in the 4 different metamers is that you have different groups around this functional group oxygen, right? Here in this case you can see you got the methyl from the one side, and you got the benzene ring attached with the CH2. Here you got again the OCH3, but here you got the benzene and you have a methyl at the ortho position here, right? Here you got at the para position, the methyl. Here you got at the meta position the methyl group. So these are the different metamers having the same functional group, and only difference is that they have the different alkyl groups around the ethereal oxygen. We find generally not only in the ethers, right? You can have in the ethers. You can also have it in the amines, the secondary amines and the tertiary amines. Like these groups, they can be same or different, right? In the secondary and the tertiary amines, even also the thioethers, the sulfur, and these two groups, they can be same or different. Even the esters, right? This is our functional group, and around this functional group, you can have different types of, these alkyl groups. So generally, ethers, amines, thioethers, and esters, they show the metamerism. Hope you got it. Thanks for watching the video. Bye for now.